Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7 and we will be presenting about crossover between two parallel tracks with an intermediate straight length. These are the members for Group 7, which is Muhammad Isa bin Muhammad Safri, me myself Alia Nadira binti Abdul Hafiz, and Muhammad Safwan Naim bin Rizwan. The contents of this video consists of introduction, 3D simulation, and also advantages and disadvantages. So first I will be explaining about the introduction for crossover between two parallel tracks with an intermediate straight length. So a cross between two parallel tracks with an intermediate straight length, often referred to as a diamond crossover. It is a fundamental component of railroad infrastructure which designed to facilitate efficient and safe train operations. Lastly, it also allows trains to switch between parallel tracks at designated points. So these are the examples of crossover between two parallel tracks with an intermediate straight length. On the right side is the schematic diagram.
So as we dig deeper into the simulation part, it is important to note that the simulation video will be consisting of two main parts, which is the first one will be about track layout design, and the second part of it will be about the movement of the passenger car. So before we go into details regarding our simulation, I suppose it will be better for us to give an introduction towards the simulation application that we are going to use, which is AnyLogic Rail Library. It refers to a specialized simulation where it offers modeling rail system. Its initial intention was primarily to use for simulation in which we could intricate rail networks, train operations, and related logistic procedures. It is also considered as an extension of the AnyLogic multi-method simulation platform, and one of the key features that we would like to highlight in our presentation will be the rail infrastructure modeling, train modeling, and dynamic train scheduling. So by referring the figure that we have provided on the bottom right of this video, we will need to construct the railway track, which isn't the most complex one, as it only consists two parts of straight lines track, and a partial part of it will be a curvature one. But it is really vital for us to be precise on constructing and connecting the curved part together with the straight line part so that it is not disjointed. As for the track gauge, we'll be using 1.5 meters and will be the railroad type of track.
Now, for the passenger car movement, we have to add position on track to define the location where the train will go, and then we put that as terminal A, and then we add second position on track to the track, and then as a terminal B as a second point, and we put a position on track from as a terminal C as the third point. And then moving on to the block section, we have train source where we customize the train properties, and then we add a prom delay. We add a prom so the train can be delayed and not continuously moving without stopping. And then from the trail part, we have to apply the train move to prom, and then repeat the sequence of delay and train move to for 3 times, because at the terminal C and terminal B, the train will have to move back and forth, and then they proceed to the terminal A. So at the end of the prompt, we need to do a loop, so the train will move continuously like shuttle. So now for the next one is we need to customize for every prompt. First we need the rail car type, choose a rail car type, and then for the train source we need to customize where the interval time, maximal arrival, and including the numbers of the cars lah. And then rail car we choose as a passenger car with the length of 10 meters, and then we choose the interval time is around 10 seconds. 10 minutes is quite long, so now we moving on to adjust the delay time, is for 5 seconds. And then for the train move to, we need to define the position of the track and whether the train have to move backward or forward, and we repeat the step on the delay, the second delay and the third delay. And also for the train move to, we need to specify the point where the train has to move. Then after that all steps are done, customizing the prompt, and we should add a 3D window to start the simulation, so we can see the 3D simulation, that how it works. And after that we start the simulation, and we can see that the train is moving from the crossover track with an intermediate straight fluently from terminal A to the terminal B and terminal C, and go back to the terminal B and then to terminal A and repeat the process. So basically the simulation shows how the crossover and also with intermediate straight double track, how it works. Alright.
The advantages of using this type of track will improve flexibility, which the crossovers provide flexibility in routing trains between parallel tracks by allowing for efficient management of train movements, especially in areas with limited space. Next is reduce congestion. They can help reduce congestion and delays by enabling trains to switch tracks, which can be crucial for maintaining schedules and also safety. Next are the disadvantages. First is cost and complexity. Building and maintaining crossover tracks can be costly and complex. This is due to the need for precise engineering and also signaling systems. The second disadvantage is limited capacity. While crossovers can help with routing and flexibility, they may have limitations in handling heavy traffic, and also excessive use can lead to bottlenecks and delays. Last but not least is the conclusion. The utilization of crossovers should be based on a comprehensive assessment of the railway network's needs, taking into account factors such as traffic patterns, available space, and safety considerations. The implementation also should be approached with careful planning and a commitment to ongoing maintenance to ensure the continued safety and functionality of the railway infrastructure.